In this video, we see more examples of separable differential equations. As usual, my suggestion is try to do the example on your own before watching my solution. The first example, suppose, and please before watching these examples, watch the examples that we did in the previous video. So you want to solve y prime equals 1 times sine t. And at the end, you want to write the answer as y as a function of t. So here, y prime obviously is dy over dt because the variable for the function of y is t. This equals y sine t. This is a separable equation because we can move all the y's to one side, all the t's to the other side. Here, if I divide both sides by y and multiply both sides by dt, I can make that happen. So I will have dy over y equals sine t dt. These two sides are equal, so I can integrate both sides. The integral of dy over y is the integral of sine t dt. The integral on the left is in terms of y. Antiderivative of 1 over y is ln of absolute value of y. Antiderivative of sine of t is minus cosine of t. And at the end, plus c. So ln of y is minus cosine of t plus c. To solve for y and get rid of that ln, we can raise e to the power of both sides. In other words, e to the power of ln of y, which is, or e to the power of ln of absolute value of y, is equal to e to the power of minus cosine of t plus c. The exponential function and the logarithmic function are the inverses of each other. So absolute value of y is going to be equal to e to minus cosine of t plus c. As you know, I can write this as times e to the power of c. Using algebra, I can write this e to the power of c times e to the power minus cosine of t. Without absolute value, y is plus or minus e to the power of c times e to the power of minus cosine of t. Plus or minus e to the power of constant is still a constant. I can again give I can label it as just c, standing for constant. So c times e to the power of minus cosine of t. I'll use the same letter. It's okay because that c just shows that there is a constant there. So the final answer is y equals c times e to the power of minus cosine t. The next example is this equation. Now, y is a function of x, and we want to solve this differential equation. Y prime equals e to the power of x minus y. This is also separable because I can move all the terms with having y in to one side and the terms containing x to the other side. First of all, y prime is dy over dx. because the variable for the function y is x. What is e to the power of x minus y? From algebra, we know that it is e to the power of x over e to the power of y. So if I divide both sides by dx and also, I'm sorry, if I multiply both sides by dx, so I repeat that, if I multiply both sides by dx and at the same time multiply both sides by e to the power of y, I will have e to the power of y dy equals e to the power of x dx. So I integrate both sides. Antiderivative of e to the y, let me write it here, is e to the y. Antiderivative of e to the x is e to the x, and at the end we need a plus c. So y itself is, so if e to the y is the other side, if I take a natural logarithm from both sides, y is going to be ln of absolute value of e to the power of x plus c. And that's the final answer. Let's see another example. Again, please try this on your own before watching my solution. And this is y prime, which is dy over dx because the variable here is x, equals x over y squared. So y is a function of x, so it is dy over dx, x over y squared. Multiply both sides by dx and also multiply both sides by y squared. We'll have y squared dy equals x dx. So we integrate both sides. The integral of y squared dy is the integral of x dx. We continue on the next page. Antiderivative of y squared is y cubed over 3. This equals antiderivative of x on the other side is x squared over 2. And we need a plus c at the end. So to solve for y, first let me multiply both sides by 3. So y cubed is 3x squared over 2 plus 3c. But 3c is still a constant. So I can just show it by a c. So it means that y cubed is 3x squared over 2 plus c. So that c just means a constant. That's why I replaced 3c by c. And so y is cube root of 3x squared over 2 plus c. I don't need plus minus because it is the cube root. In one of the examples in the previous video, since the step before the last step, we had y squared was something, that's why y was plus minus. But here, since 3 is an odd number, and to find y, we don't need plus minus here. And that's the final answer for this example. The next example, which is again a separable differential equation, is y prime equals radical of x times y. So obviously, this here y prime is dy over dx. The variable of y is x. So dy over dx is radical xy. As you know, radical xy is radical x times radical y. So if I multiply both sides by dx and at the same time divide both sides by radical y, what I will get is dy over radical y equals radical x dx. These two sides are equal, so the integral of the left side equals the integral of the right side. Let me continue on the next page. Antiderivative of 1 over radical y with respect to y, as you have seen even in Calc 1, is going to be 2 radical y. Antiderivative of radical x, radical x is x to the power of 1/2. Using the power rule, it's going to be 2/3 x to the power of 3/2. And we need a plus c here. To solve for y, first divide both sides by 2. So radical y is 2/3 divided by 2 is 1/3, x to the power of 3/2, plus c over 2. But c over 2 is also a constant, right? So this is just a constant. So what we can do is radical y is 1/3 x to the power of 3/2 plus a constant c. To find y itself, I raise both sides to the second power. So y is going to be 1/3 x to the power of 3/2 plus c all squared. And that's the final answer.